Okay, hello guys, and welcome back to my channel. George Boomer Smith here with you guys again. Now, this is going to be the first video in this series of videos where I'm going to be talking about some intermediate topics in the Python programming language. Most of them are just specific to Python. Others, I think, they are general concept when it comes to programming. Now, this is going to be the first video. In this first video, I'm going to be looking at iterators. Okay, we've heard this term a lot. What are iterators? What are iterables and the rest of that? That's what we are going to be looking at in this video. Okay, so without wasting most of your time, let's get started. Now, when you talk about iterators are simply containers that you can loop over. They are infinite. They have infinite number of terms, or they have countable number of terms. Let me not use the word infinite because most iterators are not infinite. We have finite and infinite iterators basically. Okay, so any item, any container, any object that you can loop over, you can transverse over, you can count the items, the number of items it contains. Those are called containers. And loops, when it comes to something like what's it called, lists, tuples, dictionaries, strings, these are inbuilt iterators. Even the range function, or if it were to be in Python 2, the x-range function, these are inbuilt iterators that comes with Python because you can actually iterate over them. Now let me just show you a quick example. For example, we have a list x, and x has a value of this iterable. You have an inbuilt function that is called the iter. For example, if I say it is equal to iter of x, what I've done so far is to build an iterator out of x. Now if I check for what x is, I try to print x, you can see that they said is a list iterator at so memory location. I've built an iterator. Now how do I loop over? How do I get the items I have in this list? All I have to do is use another inbuilt function that we call the nest function. So if I say nest of it, it's going to give me the first item, which is 3. If I go ahead and say nest of it, it will give me the next item according to what we have there, which is a 5. So the first it was 3, the second I have 5. Let's try it again. What if I say nest of it? This time it's going to give me a 3. I have nest of it, which is going to give me a 6. Okay, right? Nest of it is going to give me a 6, and that's the last item. So now what's going to happen if I try nest of it again? So this time around, if I try nest of it, I'm going to get an error. So it's saying it's stop iteration error. Okay, that's an exception basically. That's because I've gotten to the end of this iterator I have here. So x is called an iterable, and we said the reason it's called an iterable is that you can build an iterator from it, and this is basically how you build an iterator from an iterable. And that's simply what goes on when you try to use the for loop. All iterators, you can use the for loop on them. When you say for x in range of, let's say, 10, this range of 10 basically is an iterable. Okay, so what's the for loop actually does, what is going on behind the scene here is it will bring this range function, and out of the range function build an iterator from it. And how is it building an iterator? It is taking it through the iter function, okay, which could be a dunder method in that case if it's using a class, and after that it's going to be giving you things using the nest function. So there'll be a nest function until when it gets to the part where it's supposed to give you an error, where you have the stop iteration, it's going to break the loop. That's basically what's going on there, or it's going to break the function. That's what's going on there. Okay, so if I say for x in range of 10, and then I say something like print x, what I'm doing here is to build an iterator from this iterable. Then I'm looping through that iterator to bring to print all the items I have there. So that's what's happening there. But now that's what you call an iterator and what you call an iterable. Okay, and then when you move over it, you're iterating. But now I want to look at how can we build our custom iterators. Now the reason we are trying to build custom iterator is because of some other topics we have ahead. Okay, but let's see how we can build a custom iterator. Now before you can build a custom iterator, you should understand the concept of classes, because we use classes to build iterators. If you don't understand the concept of classes, I think you should look for a way to go through a video, 1 or 2, on object and classes in Python before you come back to this part. Okay, because I'm going to use classes to build iterators there. So I want to build an iterator. The first iterator I want to build is an iterator that is going to loop through to give me all cubes within a specified range Okay, so I'm going to have the keyword class. That's how you build a class. You start with the keyword class, then the name of the class. I want to give this class positive. I want to give it positive cubes. Okay, less than whatever. That's just what I'm calling a class. Positive cube less than. Now the next thing we are meant to have is our dunder method. Now there is one dunder method that we usually have when it comes to classes, and that is the init dunder method. Now the reason it's called dunder because it has double underscore and then double underscore. So double underscore method. That's where the name comes from dunder method. So the first thing you should have in this is the keyword self. Not actually a keyword actually, but you should make it self. You can use anything you want there. For some languages they use this, okay, but in Python we use self. So we have self, and then what do you want it to take? Now what we are trying to do here is this. If I'm assuming that if I call this function or I call this class and then I give it something like 20, it's going to look for all cubes that are less than 20. So the cubes less than 20, one of them positive cubes, so we have 1 is less than 20. The next value we have is 8, it's less than 20. Another cube we have, when you cube M3, you have 27, and that's greater than 20, so it's not going to take this. So the two values it's going to take are 1 and 8. Okay, so that's what we are trying to do. So what I have to do here is to pass in a value. So the value I want, I'm going to call it maxi. So that's more like the maximum limit. So that's what I'm calling it. Now this init method is not compulsory, but we're using it here because we want to carry out some initialization. So what's initialization we want to carry out here? We want to say the maximum limit should be equal to the maxi that is passed in by the user. But what I want to do here is to give this maxi a default value, so that in case the user doesn't pass in anything, then the default value should be a 1. Okay, then again I want to pick the first value that I'm going to send. Okay, let me make that a 0 for some reason. I'll explain why we're making it 0. We'll move down to that. So this is all we have in the init function. Now the next one we have is going to be, now every iterator, there's what we call the iterator protocol. The iterator protocol states that every iterator must implement 2 methods, or they must have 2 functions that belong to them. And the 2 functions they must have, according to the iterator protocols, number 1 is that they must implement, according to what we stated earlier on, they must implement the dunder iter method. That's one of them. The second thing they must implement is the dunder next method. These are 2 items or 2 methods that must be implemented before you can say such objects is an iterator or is an iterable. So I have to implement these 2 methods within this class I have here, and that's what we're about to do. So let's implement the first one. First you should implement the dunder iter function. So it's a special kind, so we just call it a dunder iter. It's going to take in self as usual, and that's all we need. But what is going to return here is going to return self itself, so it's returning the object. So what you've done here is that you're sending in an object. You've built an iterable from it because you're saying dunder iter, so you've built an iterable here. Now you're returning the iterable. That's basically what you're doing here. So that's what we have there. Now we've implemented the dunder iter function. That's all about it. The next function we need to implement is the dunder next function. So these are both special kind of functions. Okay, they have their special meaning. So according to the dunder next function, you're saying, okay, when the next function is used, what do you want to return to the user? Now here we said we want to return all positive cubes that are less than whatever is going to be specified. For example, if I give 20, all positive cubes less than 20. Okay, so what do I do here? What I'm going to do here is this. I'll pick, since self.n is equal to 0, I'm going to increment self.n by 1. Okay, after incrementing self.n by 1, I'm going to return self.n raised to the power of 3. So that's all I have here. Okay, I'm implementing self.n. I'm incrementing I'm incrementing it by 1. Sorry, so it was 0 here to become 1. Then I'm sending out the cube of it. Okay, that's what I'm trying to do here. So let's run this and see how it functions, if it's actually going to make sense. So I'm going to call, let's say the value I have is equal to positive cube less than, I want to get a positive cube less than 28. Let's use 28 as an example. So what I have to do is to say val, or nest of val, okay, nest of val, that will give me, I didn't run this, okay, they said cell. Where did I make the mistake? This self, not cell. So let's run that again. Nest of val, that gives me 1. If I try it again, that gives me 8. Try it again, that gives me 27. Try it again, that is 64. Now why is it giving us 64? Remember we said when we say positive number less than 28, there is no way it can go beyond 28, and here we're having 64 to be possible. So we are not supposed to have something like 64. We are supposed to stop at 27. In fact, we are not even supposed to get to 27, since they say it should be less than whatever value you have here. So the 27 is not less than, okay, 27 is less than, so that we would have gone to 27. So what we are going to do here is this: we have to modify this to implement this stop iter function we got here. You can see here they have the stop iter exception. So we need to look for a way to implement that here. So how do we implement that here? What we need to do is to come up with an if clause. So we can say something like, if this we have here is greater than or equal to, right, I think that should work, greater than or equal to self.maximum limits. If it's greater than or equal to self.maximum limits, I'm going to raise an exception. So we raise a stop iteration exception. But if that's not the case, then we go ahead and return this value. So let's try it again now. So I'll have this, and then I'll run this again, then move back to this. We have the first value is 1, the next value is 8, the next value is 27, and now we have an error. So what's the error saying? Stop iteration. Okay, so it's that. So we can even customize our stop iteration error by saying pass in an error, or pass in a message to the user that you can't exceed something of such the maximum limit. You can't exceed the maximum limit of, what's the value we have there? I think we have self dot max limit. So we can even customize our output like that. And let's try it again. So if I run this cell, come back to the cell, try it, I have the first value to be 1, the next value to be 8. After 8 I have 27. After 27 it said you can't exceed the maximum limit of 28, right? And that's why it's, so let's change this. Let's make it 8 this time around, or let's make it 9 and see what we're going to get. So I'll run this again, run this cell, I have a 1, run it, I have 8, run it once more, they say you can't exceed the maximum limit of 9. So this is how you build your iterable. So I can go ahead and loop through this iterable. It's very possible. How do I loop through the iterable? All I need to do is to say for x in positive cube less than, let's say 100. Okay, go ahead and print x, and you can see what we have here: 1, 8, 27, 64. Okay, the next cube after 64, it's that should be, this is 4 raised to the power of 3, I think so, and 5 raised to the power of 3 is about 125, which is more than 100. That's the reason we have just this 4 value. Okay, so that's it guys for this video, how to build your own custom iterable. Okay, so what's going to happen is in the next video we are going to build another custom iterable. Then I'll give you a different method we can use to build iterable, and that's using what they call generators. Okay, because going through this method is quite hectic, but generators are fun to work with. It's as if you're trying to create a function, but you just replace one keyword in the function, and then you have a generator which results to an iterable. Okay, so that's it guys for this video. If this video helped you in any way, do well to subscribe, click on the bell icon, and also make sure you share it amongst your friends. I'll see you guys in the next video.